Question number 13. A full fat milk is made of fat-free milk mixed with fat. Okay. So what we'll do is we'll call this as full fat as FF. Fat-free, there's two FF here. What I'll do is I'll take this no fat and this is fat. So I can now say it's made out of, which means that I can say V full flat is equal to V no fat plus V fat. Okay, we have mixed two solutions. I've got the full milk. Okay, the volume of full fat milk has a mass of so much. So what is given here? VFF is given, MFF is given to you. It contains 4% of fat by volume, which means what? We have V of fat is equal to 4 divided by 100 multiplied by 10 to the power of minus 3. Why? Because 1 into 10 power minus 3 is the total volume of the full flat milk. I have multiplied 4% of it. I've got this over here, which should now be 0.04 into 10 to the power of minus 10 meter cube. What is this now? This is the volume of the fat alone. Now what is the volume of without fat? Without fat would be VNF will be equal to 0.96 into 10 power minus 3 meter cube. How did I get to know about it? Because you know this is 10 power minus 3 here, and if I subtract this VF from 10 power minus 3, see here 0.04 in 10 power minus 3, here it is 1 into 10 power minus 3. If I subtract, I get this answer here. Okay, now what has been asked? The density of free milk is on to be density of fat free milk. What is this now? This is nothing but your rho NF is given to you. Okay, what is the density of fat? So he's asking you find the value of rho F. Okay, so now what we do is let us do it like this. So we know that when two solutions are being mixed together, the density of that, okay, will now be equal to M1 plus M2 divided by V1 plus V2. Now what is M1 and M2 here? Mass of the fat plus mass of the no fat divided by volume of the fat plus volume of the no fat. And what is this now? This is the average density, which is also nothing but the density of the full fat milk. Now you see, how do you calculate this? This is MFF divided by VFF will give you the density of this one. So what I will do is I will now write like this over here. I'll write like this over here. I'll just write 1.03. What is the mass of it? 1.035. 1.035 divided by 10 power minus 3 is equal to. Do we know the masses of the fat and the non-fat? No, we do not know. What I can do is I can now write mass equal to volume into density. Volume of fat into density of fat plus volume of no fat plus into density of no fat divided by total volume. What's the total volume? 10 power minus 3. So now we have got so much. Let us cancel these two. Then what do we have? 1.035 is equal to, what is the volume of fat? It's already given here. 0.04 into 10 power minus 3 into rho F. I do not know rho F. I'll just write like this plus volume of no fat 0.96 into 10 power minus 3 into what is density of no fat? Density of no fat is here 10 power 3, 1.04. I'll just lift this one upwards over here. So 1.04 into 10 to the power of, what is this value? 10 cube into 10 cube into 10 cube. So anyway, we don't have anything on the denominator, it's gone. So which should now be equal to 0.04 into 10 to the power of minus 3 into rho F plus, if I simplify this, what do I get here? 0.96 into 1.04. 0.96 into 1.04 will give me 0.9984. 0.9984. That's not so much. Now let us solve this. I'll write 1.035 minus 0.9984 is equal to 0.04 into 10 to the power of minus 3 rho F. This is what we have got. Now let us simplify this. So what do I get? 1.035 minus 0.9984 is equal to 9. Oh, I made a mistake again here. 1.035 minus 0.9984 will give me 0.036. 0.036 is equal to 0.04 into 10 to the power of minus 3 times rho F, our rho f should now be equal to 0.036 divided by 0.04 into 10 cube. When I do this, what do I get? Divide this by 0.04, I get 0.915. Okay, so I will write this as equal to 0.915 into 10 cube, which comes out to be 915 kg per meter cube, which is the right answer. 9.15 into 10 square. B is the right answer. Okay.